Last section for 9.5 geometric series. So we talked about arithmetic sequences, geometric sequences. Again, that's just the pattern. Then we talked about arithmetic series. That's when we're adding up multiple numbers in the pattern. Now it's geometric series. There's two different things that we're going to talk about today with geometric series. First one is going to be a finite geometric series. So R, your common ratio can't equal 1. And this is when I'm adding multiple numbers together and I have a stopping point, just like the arithmetic series. There is a stopping point, so we have this equation. So this will tell you the sum of the however number of term, your first term, your common ratio, and n is the actual number term in your ratio. Just like arithmetic series, first we have to figure out which one in the pattern this is. So we can take our 3072, and we don't know which one that is equal to. Our first term is 3, right here. We have to figure out what r is. So if I'm looking at 3 to 6, what am I multiplying each time there? I'm multiplying by 2. So from here to here, multiply by 2. That means my r value is going to be 2. So I have 2, and then it's raised to the n minus 1. We need to figure out what n is equal to. You have to figure out what term this number is in there. So if I solve this, first I'm going to divide both sides by 3. I get 1024 is equal to 2 to the n minus 1. Now my base here is 2. So what I have to do on both sides of the equation, log base 2 on this side, log base 2 on this side. And if I do that in my calculator, I get 10. So that means these two cancel, equal to n minus 1. Add the 1, n is equal to 11. So now I can use this equation right here. So I'm looking for the sum of my first 11 terms. My first term is 3. I have 1 minus my r here. My ratio is 2 going to the 11th power divided by 1 minus 2. Now when you do this in your calculator, if you don't use the fraction key, you have to put that in parentheses. So I put this in parentheses. 3, 1 minus 2 raised to the 11th power. Close the parentheses. Right here is where you definitely need that parentheses. 1 minus 2. My answer would be 6,141. So this one's written in sum notation and saying start with the first term all the way to the 20th term. This is already, I know what my r is. So my r right here would be equal to the 1/2, because remember that r is always raised to the n minus 1. I could plug in 1 if I wanted to. However, if you remember for the explicit formula, this first number is your a1. So my a1 here would be 4. I don't know why I'm using green. So now actually I have enough numbers because my n here is equal to 20 because I'm going to my 20th term. So I have all the numbers I need for this. So it's the sum of the first 20 terms equal to your first term. If you didn't trust me, you could plug 1 into this equation. That would give you 0, so that would be 1 still. So my first term is 1. 1 minus my common ratio is 1/2. This is where you have to be careful. This is going to be raised to the 20th. That whole thing divided by 1 minus 1/2. If I plug into my calculator, it looks something like this. I have it as a decimal, so I'm going to push math, change it to a fraction. Ooh, it's not going to let me change it to a fraction, so we're going to say this is roughly about 8. I'm going to round that to 8. If I were to add up the first 20 points, it would be 8, because not all of these would round it up to 8. I want you to try to do C and D by yourself. C and D. So for C, this is kind of like our arithmetic series that we had in the last video. So because we're starting at N2, there's two ways that you could do this. You could still do it to the 8 to the first when you're doing the first 10 terms, because I'm going to 10. However, then I'm going to have to subtract my first term because we're not including that one. We're starting at A2. So you could do it that way. Or since you're starting with the second term, you're really only adding up the 9 terms. 9 terms because you're not doing 8 to the first. So then my first term would be the negative 10. So it could look like this. Either way you do it, you should get negative 1,710. Second one, first, I have to figure out I have my 1/3. That's my first one. When I'm looking at what am I multiplying each time, I'm multiplying by 1/3 because the top is not changing. So each time I'm multiplying by 1/3. So that's my r value. So first I figure out what term this is. So if I figure out what the term is, So what it's equal to, this one right here is equal to my explicate formula. So first I have to multiply 3 to get this 1/3 over. When I do that, I get 1 over 2,187. Now I have to do log of base 1/3 on each side. These two cancel. Log base 1/3 of 1 over 2,187 would be equal to 7. So if you put this in your calculator, 7. Add 1 over, so now my n is 8. So now I can figure out my sum of my first 8 terms. So my first term is 1/3. My ratio is 1/3. Notice how I'm putting these in parentheses. Also, on this one, notice how if you did not get this answer, make sure that your -2 is in parentheses. That makes a big difference. So make sure you're always, whenever you're plugging in a number, it's in parentheses. If I solve that, I get 3,280 over 6,561. If you were to round that, that would be 0.5. Because this is 0.4. I'll show you. This is 0.49999. So again, that's very close to 0.5. And that's actually going to bring us to an infinite geometric series. Infinite. Saying if I were to add up the first term to forever, meaning it's never stopped, what would the number be? Now this is infinite. So you only can use this when your ratio, when it either doesn't matter if it's positive or negative, is less than 1. So it's a fraction, it's less than 1. The reason why this works is because once you get to the small numbers, once you start, because when you're thinking about this, that means your ratio is like dividing by a number. Once you get to 6 divided by 2 is 3, 3 divided by 2, and then you keep on dividing by 2, you're adding a very, very small portion when you keep on adding a number when you divide by 2. So if this is the case, then we have this easier format. So if I'm looking for an infinite, so this first one says, does it converge or diverge? The difference between this, if it's a converge, that means it's going to end up being some number. It's going to get so close to the number that you would just round it to it. Just like that last problem, I would just round it to 0.5. If it diverges, that means it actually keeps on getting bigger. The difference between this is if r is greater than 1, it would diverge. If it's less than 1, it would converge. So first when I'm looking here, it looks like I'm dividing by 2 each time. That means that my ratio is 1/2. Knowing that, because it's less than 1, I know that this right here will converge. So I know that it's going to converge. So because I know it's going to converge because of my ratio, I can use this equation. So my first term is 1. That's this right here. Divided by 1 minus 1/2. So if I put that in my calculator, that's going to be equal to 2. So once you get to the small numbers, essentially, if we would use the equation from the last page, it would be that you are getting to be 1.9999999999999. And again, that would just round to 2. So first thing I want to look to see what my ratio would be. So what am I multiplying on top? So it looks like if I look at just on top, I'm multiplying by 3 each time. So 1 times 3 times 3. On bottom, I'm multiplying by 2 each time. So now my ratio is greater than 1. It's 3/2. Even though it's a fraction, that's just going to be greater than 1. So this would diverge. So this is saying no matter what the number is, it's going to keep on getting bigger. It's not going to all of a sudden get to a point where it's 0.99999. So this one diverges. And we're done with that. I want you to pause the video and try to do C and D by yourself. So here, hopefully you notice that this is a negative right there. So since that's a negative, that means here r is actually a negative 1/3. It converges because this right here, the absolute value, that's less than 1. So again, it doesn't matter if it's positive or negative. This number right here has to be less than 1. So that converges. So my first term is a positive 1/3. Divide by 1 minus a negative 1/3 because that's your ratio. So if you were to add all these numbers up to 1/infinity, this would be 0.25. Meaning if I were to do the 1 millionth term, it would be 0.499999999. I'm sorry, 0.24999999, which rounds to 0.25. Here, I don't have a number in front. That means my A1 is 1. This is less than 1, so 2/3 is my ratio. So this converges. So 1, that's my first term. 1 minus 2/3, and I would get 3. So if I were to add up all the numbers to infinity, I would get 3. Bing, bada, boom, you are done. Have so much fun. Oh, yeah. Geometric series. Have a great, grand, wonderful day.